Hey everyone, it's another night of radicals. We're looking at section 6.2 in your textbook. We're going to learn how to multiply and divide these things. Some of this stuff you already know how to do. Some of it might be new to you. We're still working with Learning Target 1. Learning Target 1 is simplifying and mathematical operations with radicals, and multiplication and division fall under that category. All right, let's jump in. Combining radical expressions properties. This is a true statement. We've got this product property of radical expressions, and what it says is if I have the same index, and I'm multiplying radicals with the same index, what I'm allowed to do is rewrite the multiplication underneath one radical. Okay? So that's a property you should write down as is. This is the general form, and we need to know that. The second property, what's the opposite of multiplication? Division. So the quotient property says that as long as my index is the same, I'm allowed to rewrite the division of a radical. I'm allowed to put it all underneath the radical sign, and we'll learn how to take care of that. Okay, so this is two properties that allow us to move things around and put them together. Let's see how it really works. All right, let's talk here. Example A. Can we multiply? Can we simplify the product of these with multiplication? Well, those guys don't have the same index, so we can't do it. Not the same index. So don't let me catch you with that guy on a test. Don't let me let that trip you up. Let's look at B. Example B. We've got the fifth root of -5 times the fifth root of -2, and it's both the fifth root, so the product property says I can rewrite this all underneath one radical. So I can put -5 times -2 underneath the radical, and I'm going to get the fifth root of 10. And that's as simplified as I'm going to get it. 10 would break down into 5 and 2, and I don't have 5 of any certain number. Let's look at example C. Example C, I've got the same index here. It's invisible. It's at 2. So the product property says that I'm allowed to write 3 times -4. So I end up with the square root of -12. And we remember that I can write this as the square root of -1 times the square root of 4 times the square root of 3. And I know that the square root of 4 is a 2. So my answer here, oh, and I know the square root of -1 is an I. So I can write this answer as 2I, and then we're going to leave that rad 3. And that's how I simplify C. And last but not least, let's take a look at D. So D says I'm going to take the cube root of 16 and multiply it by the cube root of -2. So I can write this all underneath one radical. And 16 I'm going to write as 2 times 2 times 2 times 2. 2, 4, 8, 16. And then I've got a -2 in there. So what am I looking for? My index says look for 3. So there's one group of 3. So those 3 2's, they come out as the cube root of 8 is 2. And what's left underneath my radical? -4. Okay? So that's the product property in action. Let's see what's next. We're going to look at some harder problems with the product property. The first thing we're going to check is my indexes are the same. I know I'm looking at the square root. So what's nice is this allows me to rewrite some things underneath one radical. I'm going to simplify 45. I'm going to write 45 as 9 times 5. And then I'm going to write 35 as 5 times 7. So 5 times 7. And x to the 5th times x, that really has a exponent of 1. I have x to the 6th power. And then y cubed times y4 gives me y to the 7th because I'm adding the exponents. So when I look at this, I can say, well, the square root of 9 is a 3 because this is a pair of 3's here. So I have a 3 that comes out. I've got a pair of 5's that come out. And then I'm going to go through and I'm going to divide the exponent on the x. 6 divided by 2 is going to bring out an x cubed. And y, 7 divided by 2 is going to bring out a y cubed. And now we've got to look at what's left underneath the radical. I took care of these 3's, so they already came out. So the only number that's left underneath the radical is a 7 and a y. So when I finish and write the whole answer down now, 3 times 5 is 15, x cubed, y cubed, and what's left? 7y. So that's how we simplify those harder problems. All right, let's take a look at B. If we look at B, I'm going to do the same thing that I did earlier. I'm going to be wary of cube roots, so I'm going to really factor these things down. I'm going to put this all underneath one radical. And 2, there's my minus 2. 16 is 2 to the 4th power. 1, 2, 3, 4. So I've taken care of those. And then I've got m to the 4th and m cubed. That's m to the 7th. And I've got n to the 1st, n to the 5th, which gives me n to the 6th. So now I'm coming through, and my index says I'm looking for 3. So I've got that 2 that can come out. Then I'm going to come over and I'm going to take 7 and divide it by 3. And an m squared is going to come out. M squared is going to come out. I'm going to have 1 left over. And then 6 divided by 3 is going to give me an n squared. So when I look at what's left remaining underneath my radical, I have a 2 and a negative 2. So I'm going to write that as a negative 4m. The only thing I'm missing is, you know what, you guys, it's really important that I go put my index up here so we know that I'm a cube root. So that's how I simplify B. All right, let's tackle our last problem. Let's do example C here. Example C's got something a little different. Notice I've got this number on the outside here already. He's going to be something else I have to contend with. I'm looking at a square root because my index is 2. So if I rewrite this and I start factoring everything out, I have a 2. And then 18 can be written as 2 times 9, and 9 is 3 times 3. So that's how I factored the 18. And then I'm going to come through and look at x cubed and x to the 5th. That gives me x to the 8th. And then I've got y squared and y to the 8th. That gives me y to the 10th. So now I'm going to come through and I'm going to look for groups of 2. So a 2 comes out, a 3 comes out. I'm going to divide him by 2, and I'm going to divide him by 2. So, wow, everything comes out. I've got this original 3 out front. So, I'm sorry, that's a minus 3. So I've got my minus 3. My 2 comes out, my other 3, and then I'm going to have an x to the 4th and a y to the 5th. But that's not completely simplified. I want us to multiply this all out. So a negative 6 times 3, we should get a negative Whoops, 6 times 3 is 18. Sorry, guys. So I get a negative 18 x to the 4th, y to the 5th. And that's my solution. All right, let's look at my last problem down here. Let's take a peek at this. This is the cubed root. So the two numbers that are going to stay on the outside and I can't forget about are this 4 and this 5. Okay? So I'm going to go ahead and I'm going to multiply them out and put them as a 20. And now I'm going to go ahead and I'm going to start factoring 42. I know 42 is 6 and 7, and I know I've got a 2 and a 3, and there's my 7. And I know 12 can be 6 and 2, which is a 3 and a 2. So I'm going to look at all these numbers and write them in order. I've got 3 2s, so a 2, 2, 2. So I took care of those guys. Now I've got 2 3s, 3, 3, and then I've got a 7. And I've got x cubed now, y. And I don't want to forget that my index on here is 3. So what am I looking for? I'm looking for sets of 3. So a 2 can come out, and an x will come out. If I divide 3 by 3, 1x will come out. So I've got my original 20. I've got my 2 that I'm going to pull out. I've got 1x. And then what's left over, this is all the cubed root of 3 times 3 times 7. So 9 times 7 is going to give me 63y. So my final answer here is going to be 40x cube root 63y. That's my final answer. All right, let's go see what else we need to finish. Oh, we need to talk about division. So this is a fraction, and sometimes we need to think before we do anything crazy. And what I want you to ask yourself is 50 divided by 2, is that an integer? Is that a whole number? And it is. It's 25. So let's use the quotient property and put this all underneath one radical. 50 divided by 2 gives me 25, and x to the 6th over x to the 4th gives me x squared. Remember, I have x to the 6th on top. I've got x to the 4th in the denominator, and these guys start canceling out. 1, 2, 3, 4. I'm left with x squared. So this is much easier to deal with. Well, what's the square root of 25? 5. What's the square root of x squared? X. So I want you to think first and ask yourself that. Let's try this guy. First thing I want you to do is say, is 45 divisible by 5, and does it equal an integer? And it does. It equals 9. So let's put this underneath one whole radical. 45 divided by 5 gives me 9, and 8 x to the 8th over x squared gives me x to the 6th. So now, if I rewrite this, I have the cubed root, but 9 is 3 times 3, and x to the 6th I can take care of if I divide by 3. So I can get an x squared that comes out, but look what happens. I don't have enough 3's. So I'm going to go back and write my answer as x squared cube root of 9. Okay? All right. That's that for quotient. We need to talk about rationalizing the denominator. we can never, if you think back to 2 days ago or yesterday, we can never have a radical inside the denominator. Your geometry teachers went through this with you. This can never happen. This is really bad. And so what we do is we use this process called rationalizing. And we rewrite the denominator so there's no radicals in there anymore. So what happens is you take the denominator, it's the square root of 2. This is a fancy way of writing the number 1. In your calculator, the square root of 2 divided by the square root of 2 equals the number 1. So I'm just doing an algebraic trick. So what I'm going to do is I'm going to multiply this fraction by 1, but 1 is in a different form. So in the numerator, I get the square root of 2. In the denominator, I get the square root of 2 times the square root of 2, which is the square root of 4. But you guys are going to say, Brady, come on, the square root of 4 is 2. Well, look what happens. I don't have a radical in my denominator anymore. So I'm really happy. Okay? So we're going to go look at a couple examples of that. We're going to find the simplest form here, and we have to rationalize to the denominator. Why? Because 5 divided by 20 is a fraction. It's 1/4 or 0.25. So that's not going to work. So what we're going to do here is we're going to rewrite this as 5x squared over the square root of 20x cubed. And I'm going to rationalize the denominator. So I'm going to write the number 1 in a really fancy way. 20x cubed over 20x cubed. And now I'm going to multiply all the way across. So 20 times 5 gives me 100, and x squared times x cubed gives me x to the 5th. And my denominator is going to be, I'm going to work this out in some side work. I really get the square root of 400x to the 6th, but that's 20 times 20. So that simplifies to 20x cubed. So my denominator is 20x cubed, which is exactly what it should be. Well, now I can simplify further. I get the square root of 100 is 10. If I take that x to the 5th and divide it by 2, and x squared comes out, I'm left with a radical x in the numerator, and I get 20x cubed in the denominator. So I'm okay here. The only thing else that you guys could do, we can take a 10 out of each, or cross off the 0, so I'm left with 1/2, and my x squared can cancel with x cubed, and I'm left with 1x in the denominator. So this simplifies to the square root of x over 2x, and this is a completely legal, legitimate answer. All right, we're going to talk about rationalizing a cube root in class tomorrow. What I would like you to be prepared to do when you walk into class, I've got your Bell worksheet. I want you to be able to do these 3 problems for me, okay? So this is going to be at the start of class. All right, if you need to rewind and rewatch the video, that's great. Thank you for watching. Have a good night.